All right, welcome back. Good morning. We are resuming our conversation from last class. So, we learned how to solve linear inequalities and compound linear inequalities. And I left you all with one last problem from page 3. So, what I'm going to do is once we finish these notes, I will scan all of them and I'll send them to you. I'll actually put them in your Lumen course and then you can look at that particular problem and see how that went. Good morning, Wada. But outside of that, we're ready to move into graphing linear inequalities in two variables. So yes, we're back to graphing. We're back to, good morning, Johanna. We're back to what's the slope? What's the y-intercept? How do we graph this, right? Hopefully that how do we graph this part shouldn't be in your vocabulary, because by now you should all be very well versed in graphing lines. Let's check it out. Let's have some fun. If you have a different color pencil, if you have like a highlighter or marker or whatever, go ahead and take that out. We're going to use that today. All right, let's do this. I'm excited. Okay, graphing linear inequalities in two variables. So the first thing we're going to do is we're going to recall this slope-intercept form, and that is y equals mx plus b, where m is our slope and b represents our y-intercept. And remember, your y-intercept is always of the form 0, comma b, okay? Our point will be on the y-axis. Now, there's a couple things we have to consider when we graph linear inequalities. So the first thing we have to consider is, is our line solid or is it dotted? So now here's the trick. We will know if our line is solid if the inequality symbol, good morning, Patrick, if the inequality symbol is less than or equal to or greater than or equal to. So kind of think back to what that looked like from our reference table. When we had less than or equal to, it was a solid circle, right? Or it was a bracket. So think of this in the same way. If it's less than or equal to, greater than or equal to, we have a solid line. So solid line, solid line. When our inequality symbol is less than or greater than, recall that on a number line that would refer to an open circle or a parentheses. We talked about that as like an open door almost. And when you think of a line being open, I hope that you would all consider that that implies that it is a dotted line, okay? So less than or equal to, greater than or equal to, that's a solid line, solid line, solid line. When it's less than or greater than, it's a dotted line, okay? That's something you really have to pay attention to. That's the first of two things you need to definitely pay attention to. The second thing we need to pay attention to is where in the heck do we shade? We're referring to a specific region of solutions, right? So where would I shade? Would I shade above? Would I shade below? And for me personally, there's a couple ways of doing this. So the first way is simply to read this. So for instance, notice here that if the inequality symbol is greater than or equal to, or as an example, y is greater than x minus 2, how I like to do this is I like to look at the y-axis and I say, which of these y's are greater than the line x minus 2, right? So I think about this and I say, okay, well, all of these y's are greater than, because they're above, all of these y's are greater than this line. So essentially I say, okay, let's shade up in this region. So it's everything above that particular line. Another way we can do this is we can actually pick a point in the region we think is the region we should shade. So for instance, I'm looking at this region here and I notice that the point 0, 0 is in the region. So that's my test point. Not that I have to do this every single time, because as you get more practice, this is going to become second nature, but it's a good way to really make sure that you're doing this correctly. So if I use my test point, 0, 0, notice that every ordered pair is of the form x, then y. So my y is greater than x minus 2. What I'm going to do now is I'm actually going to substitute the 0 for x and a 0 for y, and see what this says. 0 is greater than 0 minus 2. 0 is greater than negative 2. Yes. So because 0 is in fact greater than negative 2, I know for certain that I definitely shaded the correct region. If, for instance, you thought the region was below, you can select a random point in this region and test that, and then see what happens. You'll find that it would lead to a false statement. Similarly, if the inequality symbol is less than or equal to, less than, below, right? Less, below. So we have specifically as an example, y is less than or equal to 2x plus 2. Notice first that it's a solid line because of the equal to. And then y is smaller than the line. So here's the line. We want to pick y's that are smaller than the line. So we're going to shade in the region below. Again, we can pick any test point. So just for the sake of being different, let's pick this ordered pair as our test point. That is the ordered pair 2, 0, right? So we're going to check it out, make sure we shaded the correct region. So if we write that our test point is 2, 0, we'll label that x, y. So I have y is less than or equal to 2x plus 2. Now let's plug in our values. We see that y is 0. We see that x is 2, and now let's check. 0 is less than or equal to 4 plus 4, so 0 is less than or equal to 8. Yes, it is. Wonderful. We definitely shaded the correct region. So in terms of how complicated this gets, it's literally as much as making sure that your line is correctly shaded, like your line is correctly either solid or dotted, and then make sure your region is shaded correctly. You can test that point. You can always make sure. I'm always of the opinion if it's y is less than or equal to, shade below. If y is greater than or equal to, shade above, right? Don't overthink it. It's not a big deal. Same thing goes with horizontal or vertical lines, and we'll see that too. So no worries. Let's check it out. So let's turn the page. And let's look at our first example. So y is less than 2/5 x minus 1. So as a reminder, we note that this is of the form y is equal to mx plus b, where my m, which is my slope, is 2/5. Recall that slope indicates rise over run or fall over run. In this case, we're rising because it's positive, and we always run to the right. Our y-intercept, our b, is a -1. Is this all coming back to you? Like a good dream, right? Not like a bad dream. The next thing we have to say, is my line solid or dotted? So what I like to do is I like to write them both out as a reminder. And then we say, okay, this is y is less than. So we notice here, because it's less than and not less than or equal to, that means it's open circle, open line. So it's going to be a dotted line. And then I have to determine, am I shading above or below? And then again, I read y is less than the line. Oh, y is less than, so I'm definitely going to shade below. All right, what we're going to do now is we're going to put all of these things together. So we start with our starting point, which is y, the y-intercept, which is 0, -1. So 0, give me 1 second. So we start with our y-intercept 0, -1. I'm going to plot that point. Now I'm going to apply the slope, rise 2, run 5. So from here, rise 2, 1, 2, run 5. 1, 2, 3, 4, 5. Perfect. If you wanted to, you can go again, rise 2, run 1, 2, 3, 4, 5. Sometimes it's nice to kind of have those points labeled. We can even go backwards. So instead of rising, we'll go down, down 2, and backwards 1, 2, 3, 4, 5. Because remember, from this point to the next point, you rose 2 and ran 5, right? So we're not doing anything wrong by plotting backwards. Down 2, 1, 2, 3, 4, 5. Now that I have my points in a nice line, or, visually we know it's going to be a line, let's connect this with that dotted line. Beautiful. We have our dotted line, and now all we have to do is shade below. So I'm actually going to take my highlighter, and I'm going to shade everything below my line. This shaded region represents all of the possible solutions for this particular linear inequality. Y is less than 2/5 x minus 1. And there you have it. That's all you have to do. How cool is that? Let's do it again. Number 2. We have y is greater than or equal to -1/4 x plus 6. So again, let's go through each of the steps. No need to rush it. We're going to start by saying what the slope is. The slope is -1/4, which means we're going to fall 1 and run 4. We always run to the right. Our y-intercept is our b, and in this case it's 6, so our y-intercept is 0, 6. And then we have to determine, is this solid or dotted? So notice y is greater than or equal to, so the equal to would be a solid line, it would be a solid circle, so it's definitely going to be a solid line. And then we have to determine, are we shading above or below? Well, let's read it. Y is greater than or equal to the line. Y is greater than? Oh, okay. Let's shade above. Now that we have all of our pieces, we're ready to go. Let's start with our starting point, which is the y-intercept, 0, 6. So 1, 2, 3, 4, 5, 6. Bam, there it is. Next, I'm going to apply my slope. I'm going to fall 1, run 4. 1, 2, 3, 4. Let's do it again. Fall 1, run 4. 1, 2, 3, 4. Good. I'm going to go backwards, up 1, back 4. 1, 2, 3, 4. I'm going to do it one more time. Up 1, 1, 2, 3, 4, back. Cool. So now we get to take a straight edge, and we're going to connect these. And because I only have a stapler handy, I'm going to use that as my straight edge. Hey, am I resourceful or what? I'm very resourceful. Let's go ahead and draw our arrows on either end. And of course, we're now going to shade. And we're going to shade above this time. Make sure that the shaded region meets the line as best you can. But voila, you are done. That is all you have to do. Let's turn the page and have more fun with this. This time you get to do some practice, okay? So we have, for number 3, 4x minus 2y is less than 4. So think back to Unit 4 when we graphed lines. Think back to how some of these equations were not given in slope-intercept form. They weren't always given to you in the perfect form. So sometimes you had to manipulate them, right? Sometimes you had to take standard form and turn it into slope-intercept form. Think back on how you did this. Remember, your goal is y equals mx plus b, right? Or that form. So what I'd like you to do is take a couple minutes, notice the form for number 3, manipulate it so that you rewrite it in slope-intercept form, and then, of course, graph this. So take a couple minutes to do so, starting now. That is brilliant. I love all the work that you're showing. So first things first, we need to rewrite this in slope-intercept form. So I'm going to start off by subtracting 4x, because right now our equation is in standard form, and that's not what we want. So we bring over that 4x, that leaves us with -2y is less than, and instead of writing 4 minus 4x, we learned a long time ago, we want to write this in descending order. As a reminder, you do not change the direction of the inequality sign if you add or subtract, right? That doesn't do anything. It's only in the case where you multiply or divide by a negative number, like we're about to do now. I'm going to divide each term by a -2. Notice how I've written this out so that it's super clear that I'm dividing every single term by a -2. And because I am doing this, I have to flip the direction of the inequality symbol. So that leaves me with y is greater than, and then negatives cancel, leaving you with a positive, so 2x. And then a positive divided by a negative is a negative, so 2x minus 2. Notice my slope here is a positive 2. I'm going to write that over 1 just so that we know it's rise 2 and then run 1, always to the right. My y-intercept is the ordered pair 0, negative 2. I then have to consider, is this line solid or dotted? And of course, do I shade above or below? So looking at the inequality that we have here, y is greater than, so greater than first off tells me I'm definitely going to shade above, but also because it's greater than and it's not greater than or equal to, I recognize that this is going to be a dotted line. All right, so let's get this started. 0, negative 2, 1, 2, here we go. Rise 2 units, run 1. Rise 2 units, 1, run. Wow, let's try that again. Run 1. Rise 2, run 1. That's good enough. So we're going to make this line dotted. I said that's good enough, but here I am. Perfect. And then we're going to shade above. Remember, if you're like, which part is above? Look at the y's. Look at the y-axis. All of these points are above this line. So we are going to shade this region. Excellent. Excellent work. Excellent work. Yeah, that's okay. That's okay, Kayla. Rachel, Doc, Ryan, Noelia, Patrick, Kevin, everyone, beautiful work. That was fantastic. Let's take a look at number 3. Number 3 is a little bit different, but not really, right? We still have to isolate y. The cool thing about this is we don't really have to add or subtract any terms. You just got to get y alone. So when you look at this, negative 3x is greater than or equal to 6y, you would say, okay, well, I need y by itself, so it must be that I have to divide by 6. And we're going to start this way. So if I divide both sides by 6, that leaves me with negative 3 over 6, which reduces to negative 1 over 2x. I do not have to flip the direction of the inequality symbol because I divided by a positive 6. So this stays, and then 6y over 6 is simply y. So let's go through the motions of figuring out what my slope is, which is negative 1 over 2. This means I'm going to fall and then run. My y-intercept, now this is interesting. Recall that the slope-intercept form is y equals mx plus b. But there is no plus b. Oh, so it's plus 0? Got it. So my y-intercept is 0, 0. We've seen these before. It's just been a long time. So I could understand if some of you are like, wait, how do we do this again? It's okay. So our y-intercept is 0, 0. Next, let's determine if we have a solid or dotted line. Well, by looking at the inequality symbol, because we have the equal to, we know it's going to be solid. And now here's the part we have to be really careful about. Are we going to shade above or below? Well, if I read this, it says negative 1/2 x is greater than or equal to y. But anytime we determined where we were going to shade, didn't we always start with reading y and then the line? So I'm going to read this as y is less than or equal to negative 1/2 x. Y is less than, so we're going to shade below. And again, what I'm actually going to do for this one in particular is I'm going to test it because I want you all to be confident with what we are doing together. So I'm going to graph it and I'm going to shade it, and then I'm going to pick a point in that region to test. So 0, 0 is my starting point. I'm going to fall 1, run 2, fall 1, run 2, do it again. I'm going to go up, backwards 2, up, backwards 2. It is a solid line, so I'm going to take my stapler as my straight edge. Works pretty well. And then I have to shade below according to my analysis. So I'm shading everything below. And then I really want to be confident. I want to say, yes, I definitely picked the correct region. So I'm just going to pick a point somewhere in here. And actually, I'm just going to choose this point. This ordered pair here is 0, comma, -1, -2, -3. So our test point, and again, I just chose it. You can choose any test point you want. I've chosen 0, -3. So we have -1/2 x is greater than or equal to y. Some people suggest testing in the original equation, which we could if you wanted to. So I'm going to write, or let's test this in -3x is greater than or equal to 6y. Either way, it should work, right? If you did the math correctly in simplifying the equation, writing it in slope-intercept form, then either way, this should be perfect. But I'm okay with trying both. So we're going to plug in a 0 for x and a -3 for y. -1/2 times 0 is greater than or equal to -3. So -1/2 times 0, 0. Is that greater than or equal to -3? Yes, it is. So let's plug in 0 for x and a -3 for y just to make sure. Again, it's all about building confidence. So we may as well take steps to build that confidence and to feel good about the math that we're actually doing. -3 times 0 is 0. Greater than or equal to 6 times a -3 is a -18. Is 0 greater than or equal to -18? Yes, it is. So we know for a fact we shaded the correct region. Keep that in mind. There's no reason for you not to test your work. There's no reason for you to not say, you know, I'm not totally certain, but let me just pick a couple points, test it out, see how that works out. Do this. You have the opportunity, you have the time. Don't rush it, okay? Let's turn the page, keep going. Check out number 5. For number 5, we have x minus 3 is less than 1. Any of you who see this right now, first off, you're probably saying there's no y, but then if you think back to Unit 4, you know this is okay. Then next thing you're probably going to say to yourselves is, I got to get x alone, right? As a mathematician, I'm trying to solve. And in this case, I can isolate my variable in question so that I can solve. So I'm going to add 3 to both sides. This is going to leave me with x is less than 4. Now, this is interesting because we have to go back to what kind of equation or what did the graph of the line look like for something similar to this. So for instance, like x equals 4. When we think back to graphing x equals 4, I hope you all recall that that was a vertical line, right? What we ended up doing with something like x equals 4 is we ended up writing a couple ordered pairs, but we made sure that x was 4 because in essence we're plotting that line. Now with this particular example, we know that the line is either going to be solid or dotted, so we have to make that determination, and we still have to shade. So those things don't go away. We just have to think back to Unit 4 to say, well, what would something like that look like? So what I'm going to do is I'm going to write 2 ordered pairs that are on this particular line. So let's check this out. So we know that 4, 0 is definitely on this line. So 1, 2, 3, 4. And then we know that for, and I'm just going to write another, the y variable doesn't matter. So 4, 1 is also on this line. Let's make the determination. Is this solid or dotted? Well, because x is less than 4, recognize that this is not equal to, so this is going to be open line, or in other words, dotted. Then we have to determine, are we shading above or below? And we'll figure out what that means in a second. Because this says x is less than 4, doesn't that mean like 3, 2, 1, 0, -1, etc.? So we're definitely saying below. Okay, having said that we know it's a dotted line, we recall that x equals 4. So recall, x equal 4 is a vertical line. Remember that every vertical line, wow, I can't write. Let's try that again. Every vertical line has a slope that is undefined. You remember that? I'm sure you do. I'm positive you remember that every vertical line has a slope that is undefined. So this is a dotted line. So let's go ahead and carefully draw in our dotted line. Hopefully that's visible to you all. And then x is less than 4. So now when we think about where we shade, we know that if we go to the right, these x values are getting greater. So 5, 6, 7, 8, 9, they're getting bigger. But if we go to the left, we're going smaller, right? 3, 2, 1, 0, -1, etc. And we want x is less than 4. So naturally, we should shade below, which in this case means to the left. Okay? Your turn, same concept. Go ahead and try number 6. We have -3y plus 2 is less than 14. Let's see what you got. All right, let's take a look. So we are going to isolate y by subtracting 2. That's our first step. -3y is less than 12. And then I'm going to divide by -3. So because I'm dividing by a negative, I have to flip the direction of the inequality symbol. That leaves me with the y is greater than -4. So notice that when we had y equals a constant, we were referencing a horizontal line. So I'm going to do a quick recall here. Y is equal to -4 is a horizontal line, right? And as a reminder, every horizontal line has a slope equal to 0, right? It's that horizontal line with a slope of 0. So I'm going to plot 2 points. Notice that because y is -4, we want to plot the point 0, -4, and then it could be any x value. So I'm going to plot 2, -4 because I feel like it. So 0, -4, 1, 2, 3, 4, and then 2 -4s here. So is this solid or dotted? Let's write out solid or dotted, and then let's write out above or below. Because y is greater than, I definitely know I'm shading above, but also because it's not equal to, I know that this is going to be dotted. So I'm going to go ahead and make my dotted line carefully so that it's very visible to everyone. And then, of course, I'm going to shade above this line because we want our y values to be greater. Shade this appropriate region, and we're done. Very nice. I wanted to give you all exposure to vertical and horizontal linear inequalities. That way you can practice graphing those, and of course, ones that you had to rewrite in slope-intercept form to be able to graph. I have a couple challenge problems to finish off this unit. On the next couple pages is an overview, so I'll just show those to you briefly, but it's an overview of the entire unit. So take a look at these 2 challenge problems. What I wanted you to have an opportunity to do was to try to go backwards. So instead, what I did was I've given you the graph. What I want is the inequality, right? I want the y equals mx plus b form. So you'll have to think about what is the slope? What is the y-intercept? And what I'd like to do with you is, because this is a little bit hard to see, I'm going to try to zoom in a little bit, right? But it's a little hard to see, so I am going to do this with you. But I'm going to go through this nice and slow so that it gives you an opportunity at home to try to do this quicker than I'm about to move through this. So one of the things we should be thinking about when finding the equation of this graph is we have to say to ourselves, well, I should identify what the slope is, and I should identify what the y-intercept is, right? So I'm going to start here, and I'm going to look, and I'm going to say, well, the y-intercept is crossing here at 0, 7. That's the first thing. That's super helpful. Next, I'm going to follow the line until I hit a perfect point. So notice that I follow the line and I hit a perfect point here. I'm going to do it again. I hit a perfect point here. I'm going to do it again. I hit a perfect point here. So I'm noticing a pattern. I'm noticing that to get from one point to the next, I have to fall 2 and run 1. Fall 2, run 1. Fall 2, run 1. Perfect. So because I was able to do that many times, and identifying these perfect points, I know with confidence that the slope is -2/1. Notice here we have a solid line, so it's either less than or equal to, or it's greater than or equal to. It's one of those. And then also notice that I shaded below. So because I shaded below, we're going to say that this is going to be less than or equal to. With all of this information, I'm ready to write my linear inequality. The linear equality associated with my graph here is going to be y is less than or equal to -2x plus 7. Y equals mx plus b. My slope is -2. You can write -2/1. I prefer not to. And then your y-intercept is 7. So here you have it. Not bad, right? I'm going to give you just 60 seconds to play around with this second graph. Again, I know it's a little bit hard to see, but you have the notes in front of you. Just take 60 seconds. That's it. Try to come up with your equation of the linear inequality, and we'll check together, starting now. All right, let's check this out. So the same thing, we need to figure out what our slope is, and we need to figure out what our y-intercept is. So the first thing I'm going to do is I'm going to scan here and find the y-intercept, and I notice that it crosses here at 0, -9. So there's my y-intercept. And now I'm going to follow this line until I hit a perfect point, and I do so right here. So I notice I had to go up 1, 2, 3, 4, and then over 1. Let's try that again. Up 1, 2, 3, 4 over 1, perfect point. 1, 2, 3, 4 over 1, another perfect point. So this is looking great. So my slope in this case is up 4/1. Now, because my line is dotted, it's either going to be less than or greater than. So now I have to notice that I've shaded above the line, right? Because all of these y values are above this line. So that means I want to pick greater than. So my linear inequality will be y is greater than 4x minus 9. And now we're done. So be super careful with that greater than or less than. If we shaded this region, we would be below the line. So because we shaded this region, we're above the line. Just focus on this y-axis. These points are above this line, okay? Hopefully that was helpful. Let me show you the next 2 pages just for your reference. So we have the Unit 8 overview, solving and graphing linear inequalities. I start off by giving you a summary of the ideas behind graphing inequalities. I've even given you an example here. I write out set builder notation, and I tell you what it actually states in my example here. I indicate the properties of interval notation, how you have to focus on the left endpoint and the right endpoint. And I've shaded a region, and then I've illustrated that in interval notation. Similarly with this one as well. I've also showcased what it looks like to solve a compound inequality in my example here. And I just wrote out a little snippet of information pertaining to compound inequalities. Lastly, I wanted to also provide some word problem advice. So in case you were looking at something like a real-world application type of problem, here's an example of that using a linear inequality. And then finally, information on graphing linear inequalities. So I'm hopeful that this visual, these kind of summaries would be very helpful to you in your learning. And as always, you can just reference the notes or reference the video. You're very welcome, Doc. I'm so glad. That's what I was going for. I wanted to be able to kind of wrap everything up in a nice, neat little gift-wrapped box, right? So that you can look back and say, oh, yeah, this is good. This is totally manageable. Okay, so we're done with the course. We have officially covered everything we need to do, and we're ready to meet in Zoom from here on out. Enjoy the rest of your day, and yeah, look for that email from me in just a couple seconds. Bye.